So in this recording, I will be solving all the problems in the tutorial. So we start with the nodal analysis. So in this problem, we need to find the voltage difference between V1 and V2. So here we have a normal nodal analysis circuit. So we have two nodes 1 and 2. So we write KCL at node 1 and node 2. Note that these two resistors will be combined in combined to form a 9 ohm resistor. So we're writing at node 1. So V1 over 9 will be leaving plus V1 minus V2 over 1 also leaving. This will equal the entering current, which is 2 amp. Then for node 2, we have V2 over 2 plus V2 minus V1 over 1, and the entering current is equal 15. So after we organize these two equations, they become 10 V1 minus 9 V2 equal 18. Our second equation will become minus 2 V1 plus 3 V2 equal 30. After the solution of these two equations, so we get V1 equal 27 volt and V2 will equal 28 volt. So the answer V1 minus V2 will equal 27 minus 28, which is equal minus 1 volt. The second tutorial problem, so we have here we have a 4-node circuit and we need to find the voltage VB. So we will rename our nodes. So we call this 1, this 2, and this 3, and this would be node 4. So VB becomes V2. So then we just straightforward write our KCL equations. So V1 over 20 plus V1 minus V2 over 40. This will equal 10. This is my first equation. The second equation is V2 minus V1 over 40 plus V2 over 100 plus V2 minus V3 over 50. Here the entering current is equal 0. Third equation, V3 minus V2 over 50. Then V3 minus V4 over 10. Here we have the two current sources, 2 entering and 2.5 leaving, so we will have 2 minus 2.5. The fourth equation, in the fourth equation, we write it here, so we have V4 over 200 plus V4 minus V3 over 10. V4 minus V3 over 10. This will equal the entering current. We have two current sources. 5 amp is entering and 2 amp is leaving. So we will have 5 minus 2. This will equal 5 minus 2. So after we organize these equations, so we will get 3 V1 minus V2 equal 400 minus 0.5 V1 plus 5.5 V2 minus 2 V3 equals 0 minus V2 plus 6 V3 minus 5 V4 equal minus 2.5 equal minus 0.5. This will equal minus 0.5. The last question minus 20 V3 plus 21 V4 will equal 600, will equal 600. So this is because we multiply the sides, so this becomes actually, it should be minus 25. Yes, well, minus 25. So after solving these four equations, so we will get V1 will equal 190.54 volt. V2 will equal 171.638 volt. V3 will equal 233.82 volt, and V4 will equal 251.26 volt. So this is our VB. So we go to our third equation here. The problem statement, we need to find the voltage across the 5 ohm resistor. This is the 5 ohm resistor, and the power dissipated into the 7 ohm resistor. So in order to find this, of course, we need to use nodal analysis. So here again, we write 3 KCL equations. So 1, 2, and 3. So first of all, at node 1, V1 minus V2 over 3 plus V1 minus V3 over 3 ohm. This will equal the two current sources, 8 and 4. 8 plus 4, which is equal 12. For the second node, V2 minus V1 over 3 plus V2 over 5 plus V2 minus V3 over 1. This will equal the entering current. We have only the 4 ohm, but it is leaving, so we write minus 4. For the third node, we have V3 over 7 plus V3 minus V2 over 1 plus V3 minus V1 over 3. This will equal the entering current. We have 5 amps leaving, so it becomes minus V. So after we organize this equation and we solve them, so we will get V1 26.73. So please always check the solution of the set of the linear equation. V2 will equal 8.83 volt. V3 will equal 8.66 volt. So here we can find that the power dissipated in the 7 ohm resistor will equal V3 square times 7. So it equals 8.6 square over 7. So actually the power dissipated will equal 65 watt, and also the voltage across the 5 ohm resistor will be V5 ohm is actually V2, which is equal 8.83 volt. So we go to the fourth question. For the fourth problem for nodal analysis, we have this circuit, we have a dependent sources, and the problem statement that we need to find I2 using nodal analysis. So in this case, as you can see that we have some dependent variable and this dependent variable is a2 and 1, so we cannot use 1, 2, and 3. So we will use a new variable. So I will call this x, I will call this y, and I will call this z. So I have three nodes: x, node x, node y, and node z. So then I can now start my writing my nodal equation. So vx minus vy over 3 plus vx minus vz over 5. This will equal the entering current, which is the dependent current source, which is 0.02 V1. This is my first question. The second question, we have V2, Vy minus Vx over 3 leaving, then Vy minus Vz over 2. This will equal the entering current with H with equal 10 amp. Please note this should be amp, not volts. This is my second question. The third question, we say that Vz minus Vy over 2. Then Vz minus Vx over 5. This will equal the entering current, which is in my case is 0.2 V3. Why we use the X, Y, and Z? So just to not be confused with the 1, 2, and 3. So here now we can simplify our equation, but we need to get rid of this dependent variable. As you can see, V1 is here, yes? So V1 will equal Vz. V1 will equal Vz minus Vy. Then V3 is here. Where is V3? Is here. It's across this 5 ohm resistor between X and Z. So V3 will equal Vz minus Vx. So what we do, we substitute this, we call them 1, this 2, and this 3. This we call them 4 and 5. So I will substitute 4 and 5 in 1 and 2 and 3. So I will get 3 equations in X, Y, and Z. Okay, so the equation that I will get here, I will get 3 equations. So 8 Vx minus 4.7 Vy minus 3.3 Vz equal 0. The second one, minus Vx plus 5 Vy minus 3 Vz will equal 60. Okay, equal 60. Last one, minus 0.2 Vx. Please check all the equations. Yeah, minus 5 Vy plus 0.85 Vz, 0.852 Vz equals 0. So after we solve these 3 equations, we will get the answer. So Vx will equal 71.11 volt. Vy will equal 78.58 volt, and Vz equal 62.89 volt. Now we are actually looking for I2. So I2 will equal Vz minus Vx over 5. So I2 equal Vz minus Vx over 5. So it will equal minus 1844 amp. So we go to the fifth problem. So here we need to find we need to find the nodal voltages. We need to find our nodal voltages. V1, V2, and V3. So here, what we have here, we have actually a sober node because there is a voltage source between node 2 and node 3. So we write our KCL as normal. So we have V1 minus V2 over 5 will be leaving, plus V1 minus V3 over 1 also leaving. This will equal the entering current. We have 3 amp entering, 5 amp leaving, so we say 3 minus 5 will equal minus 2. Then now here we cannot write KCL at node 2 or 3, so what we do, we combine them together, then we write KCL at this sober node. So V2 minus V1 over 5, then V2 over 3, then V3 over 2, then V3 minus V1 over 1, V3 minus V1 over 1. This will equal the entering current to this sober node. So 5 amp is entering, 8 amp is leaving, so we say 5 minus 8 equal minus 3. So we have first equation, the second equation. Then how we get the third equation? It's easy because we can see that V2 minus V3 will equal 4 because V2 is at the positive polarity. So after we organize these equations, they become, so the first equation becomes 6V1 minus V2 plus 5V3 equal minus 10. So this is my first equation. My second equation becomes minus 18 V1 plus 8V2 plus 22.5 V3 is equal minus 45. This is my second equation. My third equation is to clear that minus V3 plus V2 equal minus V3 equal this minus 4, or you can use this one, same equation. So after the solution of these three equations, then V1 will equal minus 8.6 volt, V2 will equal minus 3.6 volt, and V3 will equal minus 7.6 volt. So we go to problem number 6. So here we need to find the voltages V1 and V2. Here it's clear that we have a sober node between 1 and 2. So we will write a single equation for the sober node, then we can say that V1 minus V2 equal 9. So at node 1, V1 over 5, the current flow is 1, then V1 minus V2 over 1, then V2 over 9, then V2 over 9. Then we can count also the current here, V2 minus V1 over 1. This will equal the entry current 3 minus 5. So this will equal minus 2. Again, if you have a voltage source between two nodes, then you form the super node. But remember here, you have also the resistor between them. So we can combine them together. So there is no need for this. There is no need for this part. Because actually what you can see, V1 minus V2, V2 minus V1. So this will cancel each other. So you can just straightforward write this V1 over 5 plus V2 over 9 will equal 3 minus 5 will equal minus 2. So this is your first equation. Second equation will becomes V1 minus V2 equal 9, or V2 minus V1 equal minus 9. So after the solution of this equation, so V1 will equal minus 3 is equal minus 3.2143 volt, and V2 will equal minus 12.2143. We go to question number 7. In question number 7, what we have here, we have to determine the voltage V. Okay, we need to determine the voltage that we call it V. So here we will call this one. So here, now when you look at this circuit, what we have here actually, we have a super node between these two, and we have one of the node and the ground. There is a what we call it, a voltage source. So also we need to so this becomes we call this 1. So we call this 1. Then we call this 2. So by the way, you can call them any number that you need. Okay, so what that you can use 1, 2, then 3, then 4. So remember what you do here. You have this node with the ground. You have here super node. Okay, so we straight away can write at node 1, we say V1 equal 5. This is my first equation. At node 2, we have V2 over 2, this current, then plus V2 minus V3 over 10. The current that entered this node is actually minus 1. So this is my second equation. My third equation, I can say V4 minus V3 equal 10. V4 minus V3 equal 10. So this is my third equation. From where I can get my fourth equation, of course, we will use the super node, which is formed by node 3 and 4. So for this node, we say V3 minus V2 over 10. V3 minus V2 over 10 plus V3 over 20. Because remember, this is my ground. This is my ground. Then V4 minus V1 over 12. V4 minus V1 over 12. This will equal the entering current. We don't have any current here. We have here entering current, which is equal 5. So this is my fourth equation. So after we organize them, so I will write the organized equation here. So I will have 0.6 V2 minus 0.1 V3 equal minus 1. V1 will equal 5. V4 minus V3 will equal 10. The last one minus 0.0833 V1 minus 0.1 V2 plus 0.15 V3 plus 0.0833 V4 equal 5. is 833. So after you solve this, you will get the answer. Then you can get V, which is actually V2. So V1 will equal 5 volt. It's clear, yes? V1 equal 5 volt. V2 will equal 1.7314 volt. V3 will equal 20.3885 volt. V4 will equal 30.3885 volt. Okay, so we're ready to solve problem number 8. Okay, in problem number 8, what we need to find? We need to find Vx and the power supplied by the 1 amp current source. So here, what we have here actually, we have supernode. Can you see it? Usually we used to have a supernode between two adjacent nodes like 1 and 2 or between 2 and 3. But what you can see here, we have a supernode between 1 and 3. So here we cannot write KCL here or here. So I will call this is my supernode. Then I call this 1, 2, and 3. So here only I can write one equation at node 2. Yes, at node 2. So we say V2 minus V1 over 8 plus V2 over 5. This will equal the entering current, which is minus 8. Then I need to find second equation from this supernode. So V1 minus V2 over 8. V1 minus V2, V1 minus V2 over 8. Yes, this leaving. And V3 over 2. V3 over 2. This is the only resistor that we have. Then we have 1 amp is entering. So 1 amp is entering from here. And also 8 amp is entering the node from here. So we say 1 plus 8 was equal 9. So this is my second equation. So now what we need a third equation. From where we find the third equation, we can see the voltage difference between node 3 and 2 is equal Vx. So we write V3 minus V1 equal 2Vx. Now please look at your circuit. Where is Vx? Vx is here. Vx is actually V2. So just V2. Can you see now we have a third equation, V3, V1, V2. So after we organize these equations, so they become minus 0.125 V1 plus 0.325 V2 equal minus 8. The second one becomes 0.125 V1 minus 0.125 V2 plus 0.5 V3 equal 9. The last one becomes minus V1 minus 2 V2 plus V3 is equal 0. So after we solve these three equations, we will get V1 equal 3176, V2 equal minus 12.4 volt, and V3 will equal 6.96 volt. From this we can find Vx. Vx is what? Vx, can you see it? It's half V3 minus V2. It's half V3 minus V1, not V2. V3 minus V1. So it will equal minus 12.37 volt. From this we can find the power supply by the 1 amp supplied. So it's equal V1 times 1 because it's 1 amp. So the power supplies becomes 3176 watt. As you can see, Vx is negative. The power supplied by the 1 amp resistor, because V1 is positive. Can you see it? V1 is positive. So yes, V1, this source is supplying power to the circuit. Last problem in nodal analysis, number 9. In number 9, what we have to find all the 4 node voltages. So we need to find all the 4 node voltages. So here, what we have here, we have a node, a voltage source between node 1 and 2. So this becomes node 1 and the reference. So from here we can get one equation, and all the others are okay. So we can apply KCL at all of them. So first of all, we say V1 equal 1 volt. So my first question. My second question, at node 2, V2 minus V1 over 1. Then V2 minus V3 over 2. This will equal the entering current 3. So this is my second equation. My third equation, I can get it from node 3. So V3 minus V2 over what? Over 2 plus V3 minus V4 over 1. This will equal the entering current. The entering current is actually minus 2Vx. This is my third equation. My fourth equation, of course, I get it from node 4. So at node 4, V4 minus V3 over 4. V4 minus, V1. So this should be V1 over 4 plus V4 over 3. Yes, this one. Then V4 minus V3 over 1. V4 minus V3. So we don't have any source here. We say 0. So how many equations now we have? We have 4 equations. But as you can see, now we have two issues here. We have here Vx. So we cannot solve the fourth equation directly. So here what we have here, Vx, look at your circuit. So Vx is equal V3 minus V4. So we say that this equal minus 2. What is Vx? Vx is actually V3 minus V4. V3 minus V4. All the other equations are okay. So we just need to organize these equations. So V1 equal 1, then minus 2 V1 plus 3 V2 minus V3 equal to 6. This is my second equation. My third equation, minus V2 plus 7 V3 6 V4 will equal 0. My last equation, minus 3 V1 minus 12 V3 plus 19 V4. Sorry for the writing. So this one equals 0. So after we solve these 4 equations, we get V1 equal 1 volt, V2 3.0854 volt, V3 equal 12561 volt, then V4 equal 0.9512. So here we finish all the problems for nodal analysis. So please do check all the answers and please check all the numbers.